All right, this continues section 5.7. I was right in the middle of discussing the compound linear inequalities interval notation when I got cut off. So what you'll notice here is the left endpoint and the right endpoint as we graph, and what we see is the notation to tell us that the left endpoint is not included and that the right endpoint is included, and we see that those two endpoints basically just get slammed right together, telling us that we go from here to here and that's it. All right, now once we have the interval notation, we can go back and we can write all of those interval notations for all of these different graphs that we've done. So let's go ahead and go all the way back to example number 38, and I'll put these interval notations in different colors. So here what we see is my left endpoint is a 3, and then comma, and where is it going to? Well, it's going off to infinity, and so there we are. There's the interval notation. 3 to infinity. Infinity can't ever get captured, so remember it always has to have a parenthesis on it because infinity is not a number, it is an idea. Now the next one here, on the left, we're going off to infinity, but it's in the negative direction, so we call that negative infinity. And it can't ever get captured, so it has a parenthesis. And then coming up to, and where does it stop? Well, it stops at 2. Does 2 get included? Nope, so it's got a parenthesis around it. And there we go. There's our notation. All right, continuing on, part C here, we have, where's the left? Well, on the left, we're at negative 2. And negative 2 is getting included, so we use the bracket, comma, and where does it go off to? Well, it goes off to infinity, and we can't ever capture infinity, so it gets the right parenthesis on it. All right, now in part D here, we have on the left, it's going off to negative infinity, so negative infinity can't ever capture that, so parenthesis around it. Where does it come up to? It comes up to positive 5 on the right. Positive 5 gets included, so we put a bracket around it, and there's our interval notation. All right, moving on. We had standard form problems for example 40, so we're back to example 41, and you see here with the compound inequality, my left endpoint is 8, and it's included, so it gets a bracket, comma, and where does it go up to? It goes up to positive 9, and it gets included there. All right, our next one, we have a negative 2 on the left-hand side here, and does it get included? No, no inclusion. And then up to, and where does it go on the right-hand side? It goes to positive 5, and positive 5 does get included, and so there is our inequality. And then our next one, we have on the left-hand side a negative 4, and then it is not included, so a parenthesis around it. Where does it go up to? It goes up to positive 3. We'll put a bracket around that because it is included, and there's our interval notation. This one, there is no interval notation for no solution. That's the best we could do, or we could just write no solution. All right, now that puts us at solving linear inequalities. So the first thing that we're going to solve is simple linear inequalities, and then we'll move on to compound linear inequalities. Solving a linear inequality is just like solving any equation. We simplify the left and right hand side. That includes distributing, clearing if we need to, combining like terms. Then it goes to the addition property to move the variables, then the addition property to move the constants, and finally the multiplication property. But the multiplication property is the place where this could be a different process. If we have to multiply or divide, only multiply or divide, by a negative number, then the sense of the inequality must reverse. That's just fancy for saying that we have to flip the inequality after we do the multiply or divide by a negative. The first couple of examples here we have no problem with the multiply by negatives. It's the next example, example number 42, that you're going to see that in. So I'm just going to get started with the first part of example number 41 here. And this first part of example number 41 is going to show us how this is exactly the same. Now some books will indicate to you that you can just put in equal signs. Don't ever put in an equal sign because you're going to lose that inequality. The only place that I'll put in an equal sign is to show that I've used the addition property correctly, that those things are both added the same thing to both sides. So now I have x is, and then I'm going to copy down my inequality here, and then 7 minus 2, which is 5. And so x is greater than 5. And then we want to graph this on the number line, and so I'm going to graph this thing out very quickly because I'm about to run out of time.